Okay, complex numbers are pretty much when you have more than one fraction with embedded within a fraction. So in other words, here I have three fractions. I have a fraction right here, and then the whole thing is a fraction in itself. So that's what we mean by complex. It should be complex numbers, complex fractions. Sorry about that, not complex numbers, complex fractions. All right, complex numbers are something totally different. So yeah, so what we can do, whenever you have one whole fraction over one whole fraction, you can change it to multiplication. By recognizing we have the irregular divisional problem. And whenever you're dividing by a fraction, you're multiplying by the reciprocal. So let me change the multiplication to flip the fraction. And now you can cancel out whatever is in common with the top and bottom. And this is s squared. I didn't read the problem off. That is a s right there. And I got a 5rs down here. So when we look at what can cancel out, if you were to break this down, we have 4 and we have 2 w's here, 2 s's, 5rs, and 4 times 5 wr. Cancel out what's common with top and bottom. So we have 1 w that can cancel, have a 4 that can cancel, and an s that can cancel. And from there, you just multiply what you have on top and bottom. So you got w and s on top, 5r, 5r on bottom. So that's ws. 5 times 5 is 25, and r is r squared. So that's one way of taking care of complex fractions. But once again, you only can do this once you have one fraction over another fraction. Then you handle it that way. If you have multiple fractions, then we would handle it a little bit differently. But we'll get there when we get there. But questions on that one? Shouldn't have. Okay, I'll come back to that. All right, y minus 8 over 5y over 3y minus 24 over 15. So once again, set up this fraction this way, recognizing that this divisional sign is the same as this divisional sign. Multiply by the reciprocal. Factor. 15 is 3 times 5. Factor out 3. Y minus 8. Now we can cancel out what we have in common. Y minus 8, 5, And we also have a 3 that's in common, the top and bottom. Only thing left is a y down bottom, and if everything cancels out up top, you know what 1 is left? So that's 1 over y. Questions, questions. So questions on that type. Whenever we have one solid fraction over one solid fraction, we can write it this way and then multiply accordingly by flipping that fraction that follows the divisional sign and then canceling out. So question on that before we do another one that's a little bit different. All right, so this time we have multiple terms. Hold on 1 second. Sorry, guys, the kids were doing something dangerous. All right, so we have b over a plus 7b over b plus 2b over a. So here we'll take the LCD. Once again, the LCD is coming up. The only denominator that we have in this case is just a. So just all we have is a. So now we're going to multiply each term by a. So notice we didn't have, like before we had one solid fraction over one solid fraction. Here we got this, 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 and this. So we don't have that situation. So the best way to handle these, now we could go ahead and combine our like terms and all the stuff like that, or combine our fractions. But the easiest way is to take your LCD and multiply it to each term. And so what you'll notice that will happen is that we'll have AB over A plus 7AB, then AB plus 2AB over A. And now what happens is that those denominators cancel, leaving us with B plus 7AB over AB plus 2B. Questions on what happened before we finish it off? Found the LCD, multiply each term by the LCD. What that does is allow our denominators to cancel out. Then I can finish this problem by now factoring out B from each term. These can cancel. 7a plus 1 over a plus 2. Or you could have left it at 1 plus 7a. It doesn't matter.
Professor,
Yes, sir.
you're not doing no flipping, reciprocal stuff?
We didn't have to because of what I did with the LCD. I reduced it down so that I didn't have any denominators down here.
Yeah, I'll be watching this video again.
So whenever you use this method, so you want to call this one method 2. And, this method up here was method 1. If you use method 1, then yes, you're gonna have to divide by the multiply by the reciprocal when you turn the division to multiplication. But that's only when you have your fractions in this form, one solid fraction over one solid fraction. It's the only way you'll be able to do that. If you don't have one solid fraction over one solid fraction, see, I have a fraction here, term here, fraction here. If you have something like that, in which they aren't combined, if you want to use method 1, then you have to combine these first, and then combine these first, and then use method 1
What do you mean combine?
by adding them, finding your common denominator. This is a fraction over 1, this is a fraction over 1. And, do your, you can't add fractions unless you have common denominators, so you have to turn those into fractions with denominators of a. But to skip that process, you can multiply each term by this a, and you won't even have to worry about doing that. Let's try another one. Here we have 8 over x squared plus 1 over x over 2 over x squared minus 1 over x. What would our LCD be in this case?
Should it be x squared and x?
Nope, just x squared. That's good enough.
The highest power.
Right. You got it. So now if you had did x squared and x, really that would have been x cubed.
Because
And
I'm
you,
confused with chapter 7.5.
said it again?
I made that mistake because I'm thinking about 7.5, how you pick what you see the most.
Right. And so even if this was 7.5, x squared would have been your LCD. The only time you would incorporate another variable, more than that, is if you had another variable. And then it would have been x squared y. But because they're just x's, you can just use the highest power of x, and that covers all of them.
Go slow on this one.
You said go real fast? All right, gotcha. So you're just going to multiply each numerator by that x squared.
Okay, x squared get multiplied by both of them.
Yep, every single term. The ones on the bottom as well. So that's what we're looking at. So now what that does is it puts us in position to be able to cancel out denominators. So in the first one, x squared cancels out completely. The second one, just one of the x's cancel. So that's 8 plus x. And on the bottom, x squared cancels, and then one of the x's.
So I keep it straight in my head. When you're doing it this way, start canceling out the top part, your numerator first, then you cancel out your denominator.
Mm-hmm.
How did you cancel out the x squared on the numerator first?
What you mean?
Where it says 8x squared divided by x squared plus
Mm-hmm.
x squared divided by x,
Mm-hmm.
I don't see another x squared in the numerator other than with the 8x x squared.
Well, that's what we multiply. When we multiply these, you have to multiply it to each numerator.
But when you got to the second part, you canceled out x squared with x squared. I
Mm-hmm.
thought you canceled out the x squared with the 8 underneath the bottom.
Mm-mm. We're looking at two separate. When you're doing this, remember I said that you're dealing with complex numbers, so you actually have. Let me get another color here. You actually have this that you're looking at separately than this. So when you're going to reduce, I'm reducing this, then I'll reduce this, Then I'll reduce this and then reduce this separately.
Should your numerator be x squared?
Say that again.
Should your numerator at the top be 8x squared? Or
What?
I forget, you cancel out the x's. There's two x's there in the
Mhm.
numerator when you say x squared.
Right.
Got it. I see
Mhm.
it.
And then in this one right here, only one of the x's canceled, so that's why x was still left.
Okay, I get it. I'm sorry.
No, you're fine.
So basically, you factor that, turn it into two x's, and cancel out one of the x's.
Mm-hmm.
Woo, Jesus.
All right. Questions on that before we look at another one? All right. Let's see.
And this is method 2, so you don't have to do no flipping.
Right. All right. All right. N to the negative second power minus m to the negative second power over m to the negative first power plus n to the negative first power.
They're going to be fractions.
Yes, sir.
But how would I write that? 1 n over 2
Well, 1 over n squared.
squared and minus 1 m squared.
Mm-hmm.
Then divide, then 1 m 1 minus
Mm-hmm.
n1. Well, plus n1.
Mm-hmm.
So, mm,
Yep. So all you do is drop each one of them to a denominator to get rid of that negative exponent. Now, my LCD, we have n squared, m squared, m, and n. You know what LCD would be? Anybody?
I'll be honest, no. Well,
All right.
the highest power is n to the second, m to the second.
You got it. Yep. So remember, you take each one that, each different one you see, which is m and n, and then you take the highest power of the different ones that you see. So it'll be m squared times n squared. And then you multiply each by whatever you call the LCD. So we only have one subtop. I want to go black.
You multiply the top and bottom, right?
When you say top and bottom, be more specific.
When you're doing the LCD goes to both fractions. Sorry.
So we have four fractions involved,
Yeah.
and so it's going to hit the top of each fraction. And all the reason I say you got to be more specific with the top and bottom. So I don't know if you're talking about top and bottom here, or top and bottom here and here. You see what I mean?
Yeah.
So, but you're going to multiply to the top of each fraction. So that's why when we go down here, you see m squared, n squared at the top of each fraction.
Wait, scroll up again if you don't mind. So it won't be n to the fourth.
No, because the other ones are down bottom. So now, why would you say m to the fourth? I just want to make sure.
Because you multiply, I thought you had to multiply everything in the parentheses. So it'd be n to the fourth, m to the fourth, and one on the top. Then on the bottom, m to the third, n to the third.
No, that's why I said we multiplying by the numerators,
Okay.
just the numerators. We're not messing with the denominators. The n squared and the m squared are in our denominators, right? So when you look at what's going on here, n and m squared are in the denominators. We're multiplying this by the ones that are in the numerator. You see what I mean? This m squared, n squared is being multiplied by this one right here.
Okay. So we don't even worry about the denominators.
Nope, not yet. The denominators are going to cancel at some point, but we're not multiplying times the denominators.
Okay.
All right. So n squareds will cancel, m squareds will cancel, and we have one m that will cancel out with one m here, and one n that will cancel out with one n here. So what we have left is m squared minus n squared on top. And then on bottom, we have m n squared plus m squared n.
So I'm gonna be honest, I probably won't get this until I watch the video again.
It's all good, sir. That's what we're here for. It's all good.
Because I'm writing at the same time.
Mm-hmm. I understand. All right, so now we can factor. M squared minus n squared. Have our difference of squares. M plus n, m minus n. Then it's in our denominator, we can factor out m and n, just one m and one n. So if you factor that out of the first term, you'll be left with n. Factor that out of the second term, you'll be left with m. Questions? All right, m plus n will cancel, leaving us with a final answer of n minus n over mn. Questions? Any questions? All right, let's see if I can. I wrote down another one. Took a picture of another one. All right, Mr. Coley said he wanted to see another one. Have to make sure he's straight. Ain't it right, sir?
That wasn't me. Someone said something.
I'm going to use X's here instead of Z's. Don't want to confuse with any of my other things, other numbers.
Nervous.
Say again?
Modern technology got me nervous. You end up on social media and everything.
Yeah, man, most definitely not the time to be making mistakes on the internet.
So when you said Mr. Cole want to do another, I was like, okay, who said that?
All right, so
Complicated.
say that again.
This was complicated.
It's not as bad as no, I'll say it's about the same level of complication. What would our LCD be?
X to the second.
See? All right.
There, I'm lost.
So now you're going to multiply each numerator by x squared. And so don't forget that means multiplying the 6, that 1 and 1 by x squared. 21, 10, and 1 by the x squared.
I ain't worried about the denominator. Just worry about the numerator.
Yep, because the denominator is going to cancel out when everything's said and done. That's why we are doing this process. So it's x squared minus x squared over x minus 6x squared over x squared. And x squared minus 10x squared over x plus 21 x squared over x squared. Questions before we look to cancel out anything?
You can cancel. Wait.
Say that again.
Square. Can't you cancel out the x squared in the center with the in the numerator with the x squares at the bottom in the
Yep.
denominator?
Mm-hmm. So x, cancel out one of these x's. X squared cancel out completely here. So what you're left with is x squared minus x minus 6 over x squared minus 10x plus 21.
Yeah, some aliens thought this up. Yeah, we didn't think this up.
It was given to us from on high, huh? So now we can factor these two trinomials. So that'll be x minus 3, x plus 2, x plus 7. Nope. X minus 7, x plus 3. Did I leave off a sign somewhere? No, that should be plus. Sorry about that. X minus 7, x minus 3.
The x and the 3 cancel out.
Mm-hmm.
That leaves with x plus 2 over x minus 7.
Mm-hmm.
Yeah, I'm seeing it now, but wait till I get on my own.
You gotta speak positive, sir. Speak positive. All right. Questions? Any questions?
Can I recite something back real quick to make sure I got it?
Sure.
Take the LCD, only multiply that to the numerator. Do not touch the denominator of both fractions, top or bottom fractions, only the numerator.
Mm-hmm.
Then once you do that, look at both fractions, see if you can factor numbers out. Like if I have x to the second, I write that as xx and see if it cancels out with another x.
Okay. Yep, that's fine.
All right.
Mm-hmm.
Mm.
All right. Let's do at least one more. Just to make sure we're good, since this is all that we're doing today as far as new material is concerned. All right, where my problem go? All right, here we go. All right, so 11 over x plus 10 over x plus 1 over 10 over x minus 11 over x plus 1.
I'm guessing the LCD is going to be x plus 1.
Close. What are the different denominators that you see?
I see an x and an x in the other one.
Right. So the different denominators that you see is what will make up the LCD.
That goes back to 7.5.
Mm-hmm. All right. So I'll multiply each numerator by x times x plus 1. All right, so everything stays the same except we have multiplied each numerator by x times x plus 1.
We can cancel out those x's.
Mm-hmm. X's can cancel out here. The quantity of x plus 1 cancels here. X cancels here, excuse me. X plus 1 cancels here. So what we're left with now is 11 times x plus 1 plus 10x over 10 times x plus 1 minus 11x.
Can you scroll up real quick? Right there.
All right, we good to go.
Still right.
So now we can distribute. So we combine the like terms. 11x plus 11 plus 10x. 10x plus 10 minus 11x. And we can finish it off.
I got a question.
Mm-hmm.
So you distribute before you cancel out.
No, we canceled out first. We canceled out up here.
Okay.
Yeah. Canceled out here. And now that they have canceled, we distribute.
So basically, don't cancel out twice.
Right, right. There shouldn't be a second reason to cancel out. All right. 11x and 10x. 21x plus 11. 10x minus 11x. 10 minus 1x. That's all you can do with that. Questions? Any questions?
If you could bring up the book on this section,
Mm-hmm.
what's confusing about the example, I think is example 2 in the book. It's like they take the numerator and multiply it twice to the numerator and the denominator.
Mm, let me see if I even had access to that. See if I can figure out what you're talking about.
I think that's method 1.
Well, what they may be doing is combining. Um, if you use method 1, you're combining those fractions together. Let's see. Resources. Trying to see if I even have access to that book. Do you know what the problem was?
Let me log in real quick.
Hmm.
I got to figure out how to get to the other screen. I don't want to leave.
Oh, here you go. I just found ebook. All right, I got it now. So we're looking at chapter 7.
7.7.
And you said example 2?
I think in example 2, where it talks, it's like it's showing you to take the numerator and it's like a 2 there. I think it's 2x or 2n. I don't have the book in front of me.
I see example 2 is 1 over 4x minus 3 over 2.
About the first one, example
Huh?
1. What about example 1?
Example 1, 5x. Hold on. I might be able to share this. Hold on. Yeah. All right. So can you see my ebook?
Yes, I got it.
Okay. So that's example 1. That's example
Oh, you
2.
see how they got that 2x there?
Say again?
See, in example 2, it's saying
Mm-hmm.
2x. I don't even see how you get that.
Well, they combine it. Remember I said that, there's 2 ways to doing it. One way is to multiply each numerator by the LCD. That's method 2. But like you said, this is method 1.
What's the
So
LCD?
what they're doing is finding your common denominator and then combining it. So you say what times 2? They're saying the LCD is 4x in that numerator. So what times 2 will turn a 2 into 4x, and that's 2x. So it goes back to your simplifying a fraction. Let me see if I take a picture of that. I'll show you what I mean. It's like you're treating the numerator and denominator as 2 different problems, and then you bring it together.
I stopped right there. I was like, yo, I quit.
Uh, it's not that bad if you think about it in terms of the old way you would do fractions. So basically, you're looking at this as one problem, and you're looking at this as a second problem. So you say, well, how would I take care of this problem? First thing I look at is that this is my LCD of this problem is 4x. And so if your LCD is 4x, that means you want to turn both denominators into 4x. So the first one has 4x in the denominator, the second one doesn't. So you said what times 2 would turn 2 into 4x? And that'd be 2x. So you multiply top and bottom by 2x. And so that's 1 over 4x minus 6x over 4x, which would be 1 minus 6x over 4x. Now that's the numerator. Then you take your denominator and do the same thing. But here our LCD is 2x. So you're going to multiply top and bottom here by 2x. Because you have a 1 there, you want to turn that into a 2x. So that'll be 6x over 2x minus 1 over 2x. That's 6x minus 1 over 2x. And that's the other fraction, or your denominator. So like I said, this is my numerator, this is my denominator. Now I place that 1 minus 6x over 4x, and then 6x minus 1 over 2x.
And I got to flip it in, right?
Now, right, now that you're in this position of one solid fraction over one solid fraction, we can do that.
Change it to multiplication.
Mm-hmm. I didn't mean to write this in orange. Try to stay consistent. All right. And we can cancel out stuff here. I would also move, look at my positioning here.
-1.
Yep. You already see it?
Oh,
Oh,
you
let
taught me
me
that last
write this
class.
up. Say that again?
You taught me that last class.
Mm-hmm.
Professor, one's a negative and the other one's a positive.
Mm-hmm.
They can't cancel, can they?
They can if we were to factor out a negative. So you see that 2x can cancel. 4x is 2x times 2. Had a 2x in the numerator. And so what I'll do is I'll write it like this. So what ends up happening is we had a 2 cancel, and then we had an x that cancel.
But I got a negative 6x plus 1.
Mm-hmm. So if I factor out a negative, I have a positive 6 minus 1. And now 6x minus 1 can cancel.
So my answer would be -1/2.
You got it?
I'm still, in my mind, I'm not seeing that 2x thing. I don't know why I got a block.
What you mean? You talking about initially?
Yeah, I don't understand why I got a block when it comes to, it's something I got to work with.
Oh, that goes back to, adding, subtracting fractions.
6.
LCD is 6. But if you want both of your denominators to be 6, you have to say what times 2 will give me 6.
So multiply 1/2 by 3, other by 3, and
Mm-hmm.
2 and 2.
Mm-hmm. But that's the process right there.
So whatever you do to the top, you do to the bottom.
Right.
But
And that's what they did with the 2x. Where we at? Right here.
can you scroll back to the top? What I have to do to make that 2x or 4x?
You said, oh, you told me that's what you're doing? Yeah. Uh-huh.
I'm saying it out to myself. I'm
Right.
gonna have to figure out how to make that a 4x.
Right. And it was 2x that made that happen.
So that 2x doesn't have nothing to do with the other fraction at the top.
Nope, because they already had 4x. And yeah, right, because all you're doing is converting that one fraction to a denominator for a fraction with a denominator of 4x.
You see how confusing it is when you're looking in the book, you thinking that you have to multiply 2x at the top.
Yeah. But see, they're leaning on the fact that you're still holding on to your fraction principles. You know what I mean? So if I'm not mistaken, they may, and if I go back, let me look at it. They may not be explaining. Yeah, they're showing the process, but they're not really explaining it because all they say was combine. It says combine fractions in the numerator and denominator separately, which is what I said, but they didn't explain like I just explained. You know what I mean? Because they're expecting for you to know that in order to be able to combine your fractions, you have to find your common denominator, multiply top and bottom according to whatever, you know, all that stuff. So, all right. Questions? Questions on 7-7 before we do 1 or 2 out of 7-5 to reinforce.
Is there another part of chapter 7? Is there like a 7.8 or something else?
No, not that I saw. 7-7 was it. That's why I thought we had actually covered 7-7. I forgot. Like I said, we pulled back that day. All right. So this is out of 7-5. Want to solve? So the first thing we need is LCD.
Looking at that off the top of my head, the highest one is k to the second plus 5k.
All right. So now you have to look at that and make sure that you're actually looking at each piece individually. Because when you factor that, that's k times k plus 5. Right? So each individual piece that you see is k plus 5. And then here we have k plus 5 and then k, so we don't have to write anything extra. Now, if this was k plus 7, then I would have to include a k plus 7 here.
I factor out the k to the second plus 5k. I
Mm-hmm.
factor out that k that makes it k times k plus 5.
Mm-hmm.
I see k plus 5 and I see a k.
Mm-hmm.
So write everything down that I see.
Right. Yep. Because what you want to do is ensure that you're getting each separate piece or each different piece that needs to be included into your LCD.
Then I take my LCD and multiply it to my numerators.
Yep.
One problem takes up a page, Professor.
Well, sir, if we didn't do that, we wouldn't be doing much, sir.
I got you. You love math. You must love math because you teaching it.
Well, you know, I had to make a living somewhere, sir. It's all right. Pays the
You
bills.
got to love this.
So, yep, here we go. We got k times k plus 5 times each numerator. We had a 3 in the first numerator, k in the second numerator, and a 1 in the third numerator. And each denominator stays the same. I put the factored representation of our denominator down here. So that's what we have, but it's still the same denominator. Now we can cancel out some stuff.
I can cancel out a k plus 5, and a k.
Mm-hmm.
That leaves a 3. I can cancel out k plus 5. That leaves kk to the second.
And then the last one.
Just the k's. And that'd be k plus 3 because you just multiply 1,
That should be a 5.
5.
My my 3 look a little funky. I mean, my 5 look a little funky. It's supposed to be a
And the
5.
center one, I got to make k to the second.
Mm-hmm.
Then I make that 5 a negative 5.
Mm-hmm. So now we want to set one side equal to 0. We can go ahead and subtract the k as well.
Wait, you say set to 0. I thought you move it over first.
Right. Well, when you say I'm going to set one side equal to 0, that lets you know the process that you're taking now. So now you're going to subtract 5 and subtract k, and ultimately your the product of you doing so will give you that 0 on your right side of your equation.
So what I was doing is just I was moving the 5 over and subtracting it from the 3.
Yep. And that k didn't have any like terms. So all you do is bring it over,
Negative k.
subtract it from both sides.
But I still got to factor that.
Yes.
So I would do 2 times 1.
Yes. -2 and +1.
This goes back to previous chapters. I get confused on what position to make negative and what position to make positive.
Well, the greater number will take on that sign right there.
The negative sign.
Yep.
When I see a subtraction sign by the 2,
Mm-hmm.
they're gonna be different.
You
But
got it.
in order to put the positive and the negative.
Mm-hmm.
So k plus 2, k minus 1.
K -2, because remember, the greater has to take on the sign, the front sign.
Okay.
Yeah. So the greater number was the 2. So the greater had to take on that minus sign.
And my set notation would be positive 2, negative 1.
Yeah.
You did an easier one on this one.
Oh, all I did was pick one, sir. I'm sorry.
One problem take up a page, 2 pages.
Let me see.
Especially when you have a quadratic equation involved.
Mm-hmm.
I had to get up and walk away.
All right, let's see this one. I don't know if this is a hard one, but at least when it comes to the notation, let me
Oh,
make sure.
fractions.
Not necessarily a hard one, but like I said, I want to make sure we're okay with the notation and the process. Here we got 1/2 y minus 18 y to the negative first power equal to 0. So first thing we recognize is that we have this negative exponent, so make it positive. By dropping it down to your denominator.
I've seen this one before.
Mm-hmm.
LCD would be Y, right?
You got it.
Because that's what I see the most.
Mm.
And I take Y and multiply by everything in parentheses.
Mm-hmm. So even the 0, because it doesn't necessarily have to be a 0 over there. It could be anything. So you always want to make the practice of making sure we follow the procedures accordingly. So you would multiply y to each term that you see.
Now, do that y cancel out by the 2, the 1/2?
Nope, that's just gonna be y times y.
Y times y. Okay,
But
y.
the 1 in the denominator of that 18 will cancel.
Okay.
And then, of course, y times 0 is
0.
0.
Now I got a, what they call a difference, not a, yeah. Wait.
What you can do now is if you want to get rid of this 1/2, you can multiply everything by 2.
That counts out the 2s. That leaves y to the 2nd minus 18.
Close. So remember, you got to multiply everything
Oh,
by 2. Remember, in order to keep your equivalency for your equation,
36.
whatever you do to one term, you have to do to all terms. So like you said, the 2's will cancel here, leaving you with just y squared. But then 2 times 18 is 36.
Then I got the, what they call it, difference of square, not yet, what they call
Yep,
it.
yep, you got it. Difference of squares.
Then I do the square root of y. And 6
Mm-hmm.
equals 0. Well, then I got to do that set notation thing.
Mm-hmm. So each part equal to 0.
See, I'm getting in there, but once I go offline, I go brain dead.
All right. Questions, questions, questions.
Hey, did you get the one that I sent you an email I had a problem with
Let's see, let's see.
from the previous chapter? 7.5. I think I sent you two.
7.5. Man, you got to start taking a picture of something.
That's what I
So
thought.
I could just have it right here. Now I got to go searching.
I'll start taking a picture. I've been doing that. I
Well,
did.
I don't get your pictures. I just get a number. Like you got here, I had difficulty with number 14.
Yes. I didn't
Yeah.
send you a picture. I'll be honest. I ain't seen you a picture on that one.
Okay. Okay. Yeah. Yeah. Yeah.
Some of them
That
I
will
just
help greatly because
figure
then
out
I
the
don't have to
code.
go looking for it. When like right now. Like if you shoot that with that message, then I could just look at that and then because I know you be
Those the
having them for
hard
me,
ones.
so I'll be waiting.
Those ones make you want to tap out. The ones I sent you the emails on, those are the ones I'm like, look, I can't get it.
What you getting, sir? You getting it?
Thanks for the encouragement, Professor.
I mean, you doing all right. I
Hey,
think you beat
y'all,
yourself up too much.
I don't want to be monopoly the time, y'all. Anybody else got questions? Throw them out. I learned from y'all. We the only one, Professor?
Huh?
Are we the only one?
No, they here. They just soaking it all in, man. They here.
I ain't trying to monopoly.
Well, you're asking good questions, so I mean, they taking it all in.
Okay. It's like this guy monopoly all the time.
I think you're asking questions that others are benefiting from.
I don't want them saying we didn't pay to hear his voice.
Well,
Let
I
me.
think it would be a problem if you were trying to explain everything. Then they would be listening to your voice. But you're asking the question and I'm talking through it, so you're fine.
All right.
So we have 2 over, and I'm pretty sure somebody else had a question. We giving them room for it. They could ask it. It's not a big deal.
This what
So
make you
yeah,
cry
you're
right
fine.
here. This problem.
So we have 2 over h squared plus 2h minus 15 minus 3 over h squared plus 4h minus 21 equal to 4 over h squared plus 12h plus 35.
And I know I have to factor each one at in the
Right.
denominator.
Mm-hmm.
Take take each one as a section.
Yep. So we're looking at
But that goes back to what I was telling you earlier, Professor. I don't know when to put the plus and the minus or the minus or the plus.
well, that doesn't matter initially because you don't have anything in there. You know what we know. So you always, whenever dealing with the stuff, you always deal with what you know first, what you know has to happen. Then when you have stuff that you have to do by trial and error, you can factor that in, and it's easier to figure out what will not work and what will work. So we know that the first term each has to be h times h. That's the only way you can get that. Then you also know that because of this sign that you have plus or minus in your parentheses.
They're gonna be different.
Right, it has to be different. So that has to happen. Now you're saying, okay, what are my factors of 15
One
that
and
because I have different signs will subtract from each other to give us 2?
well, I got 1 and 15,
Mhm.
and I got 3 and 5.
Right. So the only factors of 15 that will subtract from each other to give us 2 is 3 and 5.
Yep.
Now, because of this sign, that means 5 has to be positive, and then the 3 has to be negative. Because 5 minus 3 is how we would get a positive 2. Now, if it was negative, then we would make the 5 negative because negative 5 plus 3 would give me negative 2.
Then that'd be my first factored one. I make that number one for that problem.
Mm-hmm.
Then I got to move on to the second one.
Right.
I got to find the factors of using the AC method. It'd be 1 times 21, negative 21. And I would say 3 times 7.
All right. So, yep. What factors of 7 will subtract from each other to give us 4? You said 7 and 3. 7 is positive and 3 is negative.
Then I break it down to the number 3.
Mm-hmm.
I'm trying to keep it in my head straight. When I say I'm doing the order, number 3, I would have to break that down.
Yep.
I would do 7 times 5.
Yep. So now here you recognize that our signs have to be the same because we have that plus sign in the back.
Now on my second sheet of paper, well, I probably on the, if I'm doing it, I'm writing it on my notebook. I'm probably on my second sheet.
Mm-hmm.
All right, now I have to rewrite everything. Oh God!
Well, when we get there, first thing we want to do is find our LCD.
All right, it's one of each, so it's going to be
Yes.
h plus 5. Wait, should I put it in reverse order? The lower numbers first.
It doesn't matter.
H minus 3, h plus 5, and h
Mm-hmm.
plus 7.
So, yep. So those 3 should be a part of your LCD.
And
H plus 5, H minus 3, and H plus 7.
then multiply that to my numerators.
Yep. So, write this down. So the way I would rewrite this is rewrite them with the factor denominators, just so we can make a clean cancellation when we go to do it. What's that? Minus 3. Yeah.
Rewrite the problem with the factor denominators.
Mm-hmm. 4. And then, like you said, multiply each numerator. I'll just do it down
I tell you, it takes up a page.
here.
2. I start doing it in steps and putting them in step forms
Mm-hmm.
and put a room on my paper.
Run out of room. Can I make it? I think I got it. I think I'm good enough.
Oh Lord Jesus.
You asked for the problem, sir.
Yeah, they put it in the homework.
We done ran over class time.
They put it in
And
the homework. It's the homework that would be tripping me up. Now, what's the easiest way to do that?
What you mean?
Do I have to take that 2 and multiply it to each one of those in the parentheses and just keep going?
No, well now remember the whole reason that you find the LCD is so that you can cancel out these denominators.
Yeah, cancel out the 5 and the 5. See, I forgot a step. 3 and 3, that leaves me 2 times h plus 7.
Mm-hmm.
I forgot that quick. That they cancel out. 3 times h plus 5. They cancel out. It'd be 4 times h minus n.
Mm-hmm.
Multiply distributed 2 to the h and then 2 to the 7.
Mm-hmm.
2h plus 14. Negative 3 times h, negative 3h minus 15 equals 4h minus 12.
Mm-hmm.
Then combine like terms.
Mm-hmm.
So negative 1h
So right, 2h minus 3h is negative 1h. 14 minus 15 is negative 1. Now you can get all of your terms with h to one side, all of your terms without h to the other.
What tripped me up was that negative h.
Uh-huh.
Go from there because I don't.
So we add h to both sides.
You don't. Whoa.
Hmm?
You add h. Oh, that it's a 1 there. You assuming there's a 1 there. I got it.
Mm-hmm. Mm-hmm. Then we add 12.
That's a
Say again?
that's 11.
Yep.
Then we got to divide 5.
Mm-hmm.
Oh, Jesus. Help me, Lord. So I got a semi clue.
Yeah, man, you're doing all right. Just got to make sure you're careful with your signs and terms because it's easy, especially with all of those steps. It's easy to miss something. So always got to make sure you're careful.
What was the other one I sent you? Or were we over class time?
Let me go back. I think that was out of 7-7 that you sent me. The last one I saw. Yeah, simplifying fractions. That one just said you didn't understand the process.
I just threw my hands up.
Yeah. Okay, number 6. Now that one you did send a picture of number 6 in 7.5. So we'll just remind me to do that next class,
Okay.
and we can knock that out. It's not a big deal.
Thank you, Professor, taking time. And
Yeah, man. No problem. No problem.
the rest of the classmate, I ain't trying to dominate the class. I just trying to get the info.
I believe you're okay, sir. And then also, if we need to set up a Zoom session outside of this, we can do that as well.
Thank you, Professor.
Not a problem. So with that being said, guys, I got to roll to this next class. Always hit me up with emails if you have any questions, or as always, you can wait till next class to ask them as well. Outside of that, you guys have a great weekend and be safe. See you on Tuesday.
Have a great weekend too, Professor Tucker.
Thanks, sir. You do the same.